Inverse functions. An inverse function switches the x and y values of a function. So that means that the domain of a function f in terms of x becomes the range of f inverse. That little -1 is not an exponent, that means f inverse. Okay? And the range of a regular function f becomes the domain of its inverse. And one way you can test to see if functions are inverses of each other is to put one inside the other, and if it equals x after you simplify, you know they're inverses. So let's try it out right here. F of g of x is going to equal the square root, and in this x right here I'm going to stick in x squared plus 4, and then I have this minus 4 out here, and if I simplify that, then I get the square root of x squared, which is equal to x. Now let's do g of f of x, and that means that wherever I have this x, I'm going to put in x squared minus 4. So that means I'm going to get the square root of x minus 4 squared, and then I'm going to add 4. When I square that, the square root disappears, add 4, and end up with x. So yes, f and g are inverses of each other. So if g is the inverse of f, then we can write g of x as f inverse of x with that little -1 symbol there. And if f has an inverse function, we say that it is a one-to-one function. Now, how do we graph an inverse function? Well, keep in mind that inverse functions are switching x and y values. So that's the same as reflecting the graph in the line y equals x, because along this line, that's your switching place, okay? So at 0, 0, nothing switches because x and y are the same. Also at this point 1, 1, x and y are the same, so nothing happens there. But how about at the point 4, 2? Okay, in the original function, it's 4, 2. On our inverse function, it will become 2, 4. And so the inverse function is doing something like this. Well, maybe I went a little bit too steep right there at the end. But it's basically going like that. And you notice that the original function and its inverse will always intersect along the line y equals x. Okay? Now, there is a way to look at a graph of a function and see if it even has an inverse, and that is called the horizontal line test. And so this function here passes the horizontal line test because no matter where I go, no matter where I put this horizontal line, it will always cross the original function at only one place. So if a function passes the horizontal line test, that means it does have an inverse. Now, how do we find an inverse function if all we know is the function? Well, we're going to use the horizontal line test to decide whether it does have an inverse function, and if it passes the horizontal line test, then we'll replace f of x with y, we'll switch x and y, and we will solve for y. So, here we go. Replace f of x with y. Oh, first let's see if it passes the horizontal line test, right? So I took the liberty of graphing this already on my calculator, and you'll see that this does pass the horizontal line test. No matter where I draw a horizontal line, it's only going to cross that function in one place. So it does have an inverse. Now I'm going to replace f of x with y. I'm going to switch x and y. And I'm going to solve for y. So I'm going to cube both sides. I'm going to add 1. And this is our inverse function. So f inverse of x is x cubed plus 1. Now remember earlier I said that inverses undo each other. So let's see what's happening to x in the original function f. F says take x, subtract 1 from it, and then take the cube root of that result. So in that order, we're going to take x, subtract 1 from it, and then take the cube root of it. The inverse says take x, cube it, and add 1. So notice that I'm doing the opposite of a cube root, I'm cubing, and the opposite of subtracting 1, I'm adding 1, and I'm doing it in the opposite order, the reverse order. I subtracted 1 first here, and I added 1 last there. So that's basically it for inverse functions.